So we're going to set up the stage here for the next panel, which is on autonomous driving. And I'm going to channel my inner Evan here, because I think people are experiencing a little bit of afternoon fade. So let's see, what would Evan say? Evan would say, "Good afternoon, everybody." And then you give this sort of weak response, "Good afternoon, sir." And then I'd be like, "Good afternoon, everybody." And then maybe a couple more times. But, you know, just bear with me.
One more time.
Okay.
Let's hear it. Good afternoon.
I think that'll do. That'll do. Okay, I'm back to professor mode. I'm not in my element. So the next panel is about autonomous driving. That's something that has been touched upon in some of the previous presentations as well. Obviously, a hugely important area of application of computer vision and machine learning. The panel will be moderated by Mike Murphy from Quartz. And the two panelists are Sanjiv Nanda from Qualcomm, based in San Diego, Qualcomm Research, and Laszlo Kishonti from AdasWorks.
I'm not gonna. Hello? Anyone there? Can you hear me? Oh, there we go. Careful now. I'm not gonna ask you how you're all doing. I think we know by now. These are surprisingly precarious chairs.
Yes.
So, as you just heard, I'm Mike Murphy from Quartz. I'm not going to introduce our panel. I'm going to let them do that themselves.
I'm Sanjiv Nanda. I'm with the Qualcomm Research, and I'm leading a program on autonomous driving at Qualcomm Research. Can say a few more words about Qualcomm Research. We've been working in things like augmented reality, computer vision, deep learning for many, many years, and it finds its way into embedded products. Of course, you know your smartphones, but most recently, I think we've been both head-mounted displays, watches, and also drones. In the last year, we have a nice product for drones that incorporates computer vision.
Hello, my name is Laszlo Kishonti. I'm the CEO and founder of AdasWorks, which is a company developing machine learning-based self-driving car software. Originally, I started in finance using artificial intelligence for time series and securities valuation. Then I started my first startup, which was in smartphones. And 2 years ago, based on the same smartphone technologies, we developed the first self-driving car, which was using a single embedded chip to drive the car. That's why we got the funding for the second company. And we focus on making self-driving available for everyone, making it very cost-efficient, using off-the-shelf sensors and off-the-shelf chips.
So before I ask you guys questions, I actually want to ask the audience a couple of questions, which I think might help. So how many of you in the audience, show of hands, have ridden in a self-driven car? Completely self-driven car, like a Google car. So about 4 people. How many people in the audience have a Tesla with an autopilot function or something similar? 1 person. Okay. How many people have a car with a backup camera or lane detection warning or any kind of beeping thing when you do something wrong? A lot more of you. And I think that kind of shows where we are right now in terms of the cameras that are in cars. It seems that most have them, but we haven't kind of gotten to that point yet of any kind of widespread consumer, like even an ability to try these things out. So I want to start with, I guess, you know, when we think about cameras and the vision systems needed in self-driving cars, we think of Lidar, radar, or even just regular cameras. But are there any other sorts of sensor systems, any other kind of vision systems that we're going to need before self-driving cars become a reality?
We currently focus most of our research on the standard cameras because they are cheap and the whole traffic system is based on visual clues. So I think that we will use in the final cars multiple sensors just to make them fail safe. But because humans do it with their own eye, I think the visual aspect is the strongest.
Yeah, I think the camera is going to take us a long way, but cameras are much more limited than eyes, and just in terms of range, resolution that we can see with our eyes, as well as the dynamic range and so on and so forth, which is why we're bringing in all these additional sensors. And yes, they're expensive, and I think there's a long way to go with making, radars and lidars get to a point where they start augmenting cameras to make self-driving cars possible. Actually, one more nice way to think about sensors is we're as a communication company, we've been involved in what's called vehicle-to-vehicle, V2V communications, and V2 infrastructure, and so on and so forth. And I think of V2V as kind of a perception beyond your sensory horizon, sort of. So whatever you can see with the camera or with the radar, even the radar that is kind of longer range than camera, I think V2V and V2I will allow you to see even further out, and that may be useful in certain scenarios.
I was thinking about that as well, especially with Evan's idea of the Internet of Eyes. Are we going to get to a place where cars, these self-driving or augmented vehicles, are going to be able to talk to each other and see what each other's cars are seeing? Are we going to have some kind of mesh network of always knowing what's ahead instead of just what's in the car? Kind of better than what a human could do. Yeah,
actually, that's kind of what I was alluding to. I think we expect that. It's a long way off because the value in sensors on your car is that you can start doing autonomy by yourself, and the value with V2V comes with the network effect. So it kind of depends on who else has these cars and when that will happen, and it may take time. Good thing is some of it is starting to happen. There's a likely mandate in North America with doing V2I and V2V. Apparently, I think New York City is one of the places where they're going to equip a lot of street lights with DSRC so that can communicate with cars. So let's see when that happens.
I have only one problem with V2V right now is that obviously the penetration is 0, and if we would have mandatory V2V in every car just right now, it would take 20 years still to get to.
So is there anything else that we're kind of missing? I mean, we spoke earlier about the idea of, that a lot of this revolves around AI systems, neural nets that need to be trained on data, need to be trained on situations, as well as just kind of rote experiences. But is the data there yet? Do we have enough information to have these reliable self-driving vehicles on the road yet?
One of the problems we see is that even if you drive a million miles, you won't see many accidents real time. I haven't seen ever real time serious accident, fortunately. And so besides we record a lot of data and we have our clients' data as well, we basically needed to set up a fully realistic simulation engine to generate CGI-based simulations of accidents, very, very bad weather conditions, etc.
So you're saying Google's million miles is not so great?
It's very useful experience, obviously, but you need to have other sources of training data as well.
I think, exactly. I think millions of interesting incidents would be much more valuable than a million miles, but of course you get that from the million miles.
And I mean, with any kind of system, there's the possibility of miscategorizing or having false positives or anything like that popping up in the system. How are we going to create situations, how can companies be aware of this, and what do they need to be careful of?
So I think currently it's kind of like a luxury or a very good feature that some of the cars have over-the-air updates. But I think that in the future, even regulators will require not just updates, but also probably a black box in every car where the last 30 seconds or 5 minutes will be stored. And it will be very similar to how the airplane market currently works, that every accident is properly documented and sent back to all the major, it's actually a public database, so every manufacturer can learn and repair.
Yeah, actually, you bring up a good point. I think that's kind of, having access to interesting data is kind of going to be really, really important. The other point with that is that there's a lot of focus on making autonomous driving possible, and the focus is all about eliminating, eliminating distracted behavior, distracted drivers kind of doing things they do inside the cockpit. But we should equally worry about how many more kind of dangerous situations we will create, because normal things that drivers do well, you drive pretty well.
I don't know about that.
Well, you drive pretty well even when you're kind of distracted, you're kind of disengaged. Basically when you're on a phone or talking or thinking, even you don't even have to be on the phone because you're kind of thinking about the problem at work and so on. So we do pretty well even when we're disengaged. And I think the big worry is, if autonomous driving is so dependent on perception, and we have problems with not just false alarms, but even misdetections and so on. So I think it's really, really critical exactly how that works, and that to Laszlo's point earlier, I think that kind of makes the case for having these diverse sensors and kind of redundant ways of gathering the same information. So that's another reason why you can't drive just with the camera.
So are there going to be, if you look at the way that people drive, for the most part, we tend to follow the rules as best as we can. But when it comes to pedestrians, we're generally erratic. People will just start crossing the road halfway through the street because they want to go right there, not wait and go 2 steps over to the cross light. How are we going to create systems that can understand or perhaps even predict every kind of crazy possibility that, a kid running into the street, a dog coming out of nowhere, how are we going to create systems that can kind of deal with these situations that we are always somewhat aware of? We always kind of are generally aware, even if we're not paying close attention, that there are pedestrians on the side and things like that. How are we going to train our computer vision systems to be aware of this sort of thing?
So I think one of the most difficult thing is that even after you recognize everything around you and classify them, you still need to predict what they will do. Obviously, the cars are usually more predictable than humans, because a child doesn't have a driver's license on the sidewalk. And it is not just enough to see that there is a human on the sidewalk, because that would be very distracting for the users of the car, that after seeing any pedestrian, it would always slow down the car. That's silly. So when you see a pedestrian, you need to analyze the behavior. Is he drunk? Is he healthy? Is his age is very low? He is a child probably following a random ball, or just a very small child without mother or parents around. And basically you need to have a very complex behavior modeling. What should you do in these kind of situations? And that's why we expect that the downtown suburban self-driving will be much later than the highway, and maybe even will be regulated by governments, especially in Europe.
I mean, that seems like a far harder problem, almost a whole separate problem of kind of like behavioral mapping and kind of understanding just the very nature of what it means to like look at someone and see what they could be doing, as opposed to just following traffic rules.
That's right. In fact, I think what we're probably going to work on first, or get there first, is kind of behavior mapping or intention mapping of just vehicles themselves. I mean, I think we pretty much understand when somebody pulls up next to you whether they want to pull in or not, and those kinds of things I think you can understand from things like video sequences and just instead of kind of what was talked about a little bit more today, which is recognizing, segmenting an image into speech parts and understanding just the content of the image. I think understanding a series of frames to know what the action is or what the intent is, I think that's first. And you do that for vehicles which are easier to kind of comprehend as to what's going on a road. And then I think the problems that Laszlo described seem hard.
Well, I mean, I wonder, like, if you think about the kind of minor accident that the Google self-driving car got in a few months ago, where I think there was like a sandbag or something in the road that shouldn't have been there under normal driving conditions. I guess the car hadn't ever seen something like that and corrected its path as any normal human would to go around that, but assumed that a bus was going to stop, and it kind of merged into the bus as opposed to not doing that. How are we going to create these systems that can predict? I mean, because that was like a series of assumptions that were built on like human assumptions, and that's why humans have accidents. Is we assume everyone else is also operating under the same emotional state, kind of biases and everything else that goes into being a human, for right or for wrong. How are we going to correct for that in that sort of situation?
There is one misconception that people think that self-driving cars will be perfect, but they won't. So you can imagine that there is very severe weather conditions can happen, and maybe two of your three, if there is three, sensors will go out or whatever. And the main reason why self-driving car is so important is because computers never tired. So self-driving cars, I don't think they will be better than the best drivers for a very, very long time. But they will be better than the average drivers. And that will already save a lot of lives.
Totally. I was driving up from North Carolina yesterday, and I don't know if anyone was outside at any given point yesterday, but the weather changed like 10 different times along the entire eastern seaboard. And it would be great to have some kind of system that, as you say, we might have this work on the highways first before any kind of pedestrian areas, that can kind of deal with those systems. And we were talking about this earlier of like the case will probably be that we just have cars when they're in very crazy situations that they just slow down, much like we would. But are there any situations? This is, I guess, a almost impossible question, but I'm going to ask it anyway. Are there any situations that we don't know the answer to that we're going to need to deal with? It's the talk a minute ago of, are we doing the right kinds of fail-safe testings before these things go on the road?
I think at least the automakers, OEMs are really worry about these things a lot. There's a term called fail operational. So they focus on failing operational. So you can pull up safely. You can find out what's around and pull up safely. You have redundant ways of doing that. So I would say, you have to kind of, I think it's all about testing and simulation and lots and doing millions of miles via either simulation or creating scenarios that where you test against, and failure scenarios and so on. So it's the hard engineering road ahead, I think.
So you can imagine what would happen if there would be a for example, an elephant escaping from the circus. And obviously, your car wouldn't be trained for an elephant or a meteorite or whatever. And when the accident happens, all the nightly news in every news channel will be about these reports that our cars are killing us because they don't know elephants or meteorites or whatever. And obviously, this is a panic, but the manufacturers and the software developers need to solve this. And the only reason, only way to solve it, to send out a patch. And then all the consumers will think that, aha, they solved it. There will be always problems. You cannot be prepared for the infinite versions available out there.
And is there anything else that we still need to develop? I mean, we were talking about this quickly before of, you know, the computer chip systems that are available. Just, are they powerful enough for the sorts of things that we're talking about here?
I think we have powerful computers, but to get them into the automobile, where the kind of the environment is pretty harsh, the temperatures go up, and chips tend to fail at high temperatures, and so I think we have to put the amount of compute that will be required. Not just for deep learning, but for computer vision, the combinations thereof. Also, I think we focus on these parts like perception, but there's also all the kind of understanding where you are, localization. Also, all the looking ahead and path planning. So anyway, there's tons of compute required for all these things, and I think we know how to go about it. We know that we take all these algorithms and they are amenable to hardware accelerations, but you need to know what those algorithms are, and then get to the hardware acceleration, because you really need hardware acceleration to get to the low power embedded compute that will get you there. So because we are some ways away from getting the algorithms done, we're ways away from getting the hardware design done, and I think, but key is that it'll require hardware acceleration, I think.
So the current AI algorithms mostly run on server side with high performance GPUs, each consuming 200 to 300 watts. It's very high power, especially in an electric car where you also need to cater for the battery. And one of the reasons why these systems are so inefficient is that they were designed for 32-bit floating point operations. But in an efficient neural network, I think theoretically it is already possible to do it with a 1-bit engine. But even the current networks can be converted into 4-bit or 8-bit integer operations. That's only one thing, so that would increase the efficiency by about 10 times, maybe more. But if you also accept that basically 70% of the weights inside the neural networks are zero, so you do multiplication 0 by 0 many times, which is totally unnecessary. If you would have a sparse multiplication or neural network engine within this 4-bit chip, then your efficiency would be at least 50 times better than what we currently do with the brute force GPUs. So there is a lot of growth possible there, and one of the things we are expecting is that the smartphone technologies went to the car to make them smart cars, and cars, self-driving cars, are the killer app for AI right now. And we will have these efficient chips, which would be 52 more power efficient than what we currently have on the GPU side. Then those chips will spread out to every other market. So it's just the beginning of everything.
So the car is the new smartphone?
It's the new killer app.
Well, in the sense that because of smartphones, there's a bunch of innovation happening, and I think because we will go invest in autonomy, it'll spawn off a lot of creative stuff that is outside the automobile.
It's interesting that, I think about the work that the U.S. government's doing, trying to regulate and trying to make a kind of positive atmosphere for self-driving cars in the U.S. And you compare that with something like drones, which it's also trying to regulate, but not quite as open arms. But I wonder, because of how integral the car is to America, America is America because of the car to a degree these days. Will this sort of, as you were saying, will this technology proliferate into other technologies that also rely on vision and autonomy, or will in the future, like robotics or drones?
I think as great as smartphones are, I think we're because they return so much value to what you do. You're willing to forgive and live with the sort of quality of software that gets embedded and so on and so forth. I think this kind of mission critical kind of consumer software that will go on in automobiles will force a different kind of discipline in the kind of solutions we put out there, and that I think is of great value. I mean, people talked this morning about security and as well as robustness, and I think there were words mentioned, and all those going to play having a dangerous thing like an automobile kind of flying around the roads and so on, being controlled by this software, will cause a nice new kind of discipline in what we put out there, and that I think has implications for how many other things that are enabled, and of course robots and drones and so on are obviously related.
So this is a random question that I've been wondering. If you look at a lot of the self-driving tests that we've seen, the companies out there doing tests, whether it's Ford or if Uber, we saw the images last week of what looked like the Batmobile, or Google with its little Panda car that looks like it has a little hat on. These are, for the most part, they're either taking stock vehicles and banging a bunch of sensors on the outside, or they're creating their own little Panda vehicles, but still with sensors sticking out in odd places that are creating these like differently shaped vehicles than what we're used to. Will sensors and vision systems necessitate a different way of thinking about the way we design cars in the future? Is there going to be this kind of like Toyota Prius for self-driving cars, or are sensors eventually just going to be small enough that they just look like cars?
We work with Volvo on the XC90. It's a big SUV where they will have self-driving versions given to consumers, which is very interesting experiment. And basically what happens there is that the designers design the car without knowing where the cameras will go. And after that, Volvo and our company try to put the cameras into places which is not really visible or not really distracting. But because of this, we need to model, for example, in computer models, what the cameras actually see because of the occlusions and where to put the cameras. And so, and what kind of lenses you want to use, what kind of resolution. So currently it's coming from the design side and then put the sensors where it doesn't hurt the design. Because cars are still kind of like beautiful objects, so the design is still important. If it's a truck, I don't think anyone would care.
So I suspect it will change. I think automakers tend to obviously focus on design, but the utility may drive you to accept, as you put it, the Prius of autonomy, sort of a design that accommodates what's needed, and maybe you don't care if it really solves the problem.
That's fair. I wear an Apple Watch, and I think it's pretty ugly. This is a 1-minute warning for anyone who has a question. Start thinking now. But one more thing I wanted to ask before I open up to questions is, we've spoken a lot about the hindrances and what still needs to happen and what is holding things back. But what sorts of opportunities do you see in the short term and the longer term out there, especially in terms of business opportunities?
So many people talk about the taxis, which I think is the hardest problem. You can imagine what will happen if a drunk guy just jump into a taxi at midnight. But a lot of journalists forget that basically to automate the trucking industry, which have very heavy regulations, for example, truck drivers cannot drive more than 9 hours a day, stuff like that. Most of the trucking is done on the highway. Will be a much bigger economic value for the whole society, because basically that means that all the goods will be delivered 2 times faster. So I think that's one of the things no one or very few people talks about.
I see. So 1 minute is up. Anyone with a question? Back over there.
Hi, Oliver Mitchell here. So just going back to the urban autonomous car question is that, so Lyft announced a week and a half ago that they're going to be starting a test in an unknown city. Chrysler just did a deal with the Google software for 100 Pacificas. And New York City is a smart city. And the Department of Transportation is going to be starting a test. So where does that figure into your timeline of autonomous mobility not hitting the urban markets when there's so much focus right now on the urban and around combining ride sharing with autonomous mobility?
So I suspect, I suspect it's accurate that autonomy is full autonomy is still further away. But these are the kinds of experiments that are going to pave the way. More likely than not, I think you'll get autonomy in some kinds of managed environments that will allow this, and so it may develop in some localized cities, some localized localities, and so on and so forth, and before it kind of rolls out, and those places may turn out to be equipped better with what's required to provide such autonomy.
And do you foresee, because I do, that by a certain time period that it'll be illegal to actually drive a car, in a high, dense, populated area?
Yeah, indeed. I think we can expect that. I think it's just the next step from having even and odd number license plates. Maybe you can have a restricted area where there's only autonomous vehicles. Absolutely.
So my earlier question was asking about timeline, but I think you sort of addressed that. Do you have a concrete kind of answer to 5 years, 10 years, 20 years that we're going to see a lot of self-driving cars around? The other question I have is it's about employment. So I read it somewhere where people are saying transportation employs most of, creating most of the jobs in the United States. Right. So having this self-driving car, where do you see those people are going to?
This is the old question, like why don't we use horses for the agriculture? So the big question is how fast the society can adapt, and many times these short-term crises create unemployment. But obviously, when our children will learn in the university, they will expect that they cannot have an employment as a truck driver anymore. So they will adapt. That's answer to your first question. It's not a good answer because there will be a lot of pain, but people will adapt, obviously. And for the timeline, I think there is currently no regulation about self-driving. So all the self-driving is currently allowed using test drivers in the US. So it is not possible to sell a self-driving car, and the legislation is really missing.
Probably time for one or two more. Right here in the middle. Oh, nope, here first. Sorry.
So you're talking a little bit about being more predictive of what humans can do, but surely that's going to be impossible without actually understanding social intent. So in urban environments, do you need to actually understand what a young child will do and how that differs from what an adult will do, and how they're all interacting with each other before you can really make something that's safe?
Sorry.
Do you, rather than just looking at behavior of humans, do you not need to understand social intent?
I think that this is more like a probability distribution question. So you might not understand the intent, but you might be able to forecast the probability distribution. So if you see, so you might need to have a simplified skeleton for each pedestrian, but you might not need to know that this guy is planning to meet with his wife and then go to shopping and type of that. But based on the motion and the variability of the motion and the variance of the motion, you might be able to create a pretty good model of the probability distribution, how not to hit them.
I think we just have one more question.
I have two questions.
One question really quickly.
Okay, one question then. So it seems like everybody is focusing on the technology development on the autonomous driving part of it, but do you guys see any trends in terms of developing technologies around the infrastructure? Because I think that's ultimately the way that, because the cars have to be in the environment and it has to communicate with infrastructure in order to make it really autonomous. So do you guys see any development or research on infrastructure side?
I think so. I think infrastructure to support autonomous driving can evolve. I think a lot of autonomy today that you can see already with shuttles that drive from airports and so on and so forth are all based on infrastructure supporting autonomy. But in public environments, again, certainly you can, once cars are equipped with V2V and V2I and so on and so forth over time, certainly infrastructure to support it will help, and that's kind of what the New York trial, DSRC trial and so on will show. So yes.
Great. Well, just want to thank the panelists and.
Thank you very much. Appreciate it, guys. Round of applause.